So let us do some problems on inverse by the method of completing the square. I will show you how to use completing the square. The name itself is telling completing the square, means we will write a quadratic equation which is not factorizable as sum of the squares. So I will take the problems. Find the ILT, inverse Laplace transform, for the following functions. So I will take up one problem. L inverse of s plus 5 divided by s square minus 6s plus 13. So how do you notice you have to apply completing the square? If the denominator is not factorizable, you have to apply completing the square. So first I will write down denominator. Completing square is nothing but, in this quadratic equation you should see coefficient of s. So I will write that coefficient of s you have to take, then you have to divide by 2, then the answer whatever you get you have to square it, then you have to add and subtract to the equation. So coefficient of s by 2, whatever you get the answer, square, add and subtract to the equation. So I have s square minus 6s plus 13. So I will write s square minus 6s. Coefficient of s is minus 6 by 2 minus 3 whole square 9. Add and subtract 9 and I will write 13. If you observe this, always this first term will be sum of the square. So this is s plus minus 3 whole square and 9 minus 13, 4. So it is 4. So you are writing it as s minus 3 whole square plus 2 square. So basically the L inverse of, I can write s plus 5 divided by, in the place of denominator I can use s minus 3 whole square plus 4. Again I will split it, L inverse of s divided by s minus 3 whole square plus 4 plus, since 5 is a constant, 5 into L inverse of 1 divided by s minus 3 whole square plus 4. So I will continue with this. So if you observe again, to find L inverse, the numerator should be of same s minus 3. So I will separate again L inverse of s divided by, I have separated, but I will add and subtract 3 because I have to get s minus 3 only to apply standard LT, and the next term I will write it as it is. So this can be again separated, L inverse of s minus 3 divided by s minus 3 whole square plus 4 plus 3 into L inverse of 1 divided by s minus 3 whole square plus 4 plus 5 into L inverse of 1 divided by s minus 3 whole square plus 4. So if you observe here, suppose just imagine you don't have 3, so it is L inverse of s divided by s square plus 2 square, which gives you cos 2t. Because s is replaced by s minus 3, pre-multiply e power 3t and here 3 into sine 2t by 2 pre-multiplied by e power 3t, and here 5 into sine 2t by 2 pre-multiply e power 3t. Why I have pre-multiplied? I have used the property of the previous property which I have used, e power 80 into L inverse of f bar of s. So first I will assume that there is no minus 3 and I have written the L inverse. Because s is replaced by s minus 3, I have written e power 3t as the pre-multiplied term.